All right, get ready, everyone, because we are diving deep today. And we're going deep into the world of agent AI. And that's not just AI crunching numbers.
Mhm.
We're talking AI that can actually act like in a game or a robot even.
Yeah, it's pretty fascinating. It's like AI is becoming a character in a story or controlling a character, maybe even,
Yeah.
moving from passive AI to AI that makes decisions and takes actions, to achieve goals.
Oh, that's a cool thought. Okay, so we're not just talking about like AI writing a poem. We're talking about AI that can play a game or even control a whole system.
Exactly. And to really get into how this all works, we are going to look closely at this research paper, Agent AI, surveying the horizons of multimodal interaction.
I'll admit that title is a little intimidating,
It is a mouthful.
but I'm sure it's got some good stuff in there.
Oh, it's packed with insights, yeah. One of the really key ideas in this paper is this idea of multimodal interaction. So instead of just processing one kind of data, like text or images, these AI agents, they can combine information from all sorts of sources. It's like giving them different senses.
So it's not just understanding what you say, but also what it sees, what it hears,
Yeah.
taking in all this different data at the same time.
Yeah, exactly. It's like an AI watching a movie, listening to the dialogue, and understanding the emotions of the characters all at once.
Wow, that's pretty amazing.
Yeah, it's super powerful because this multimodal capability, it really lets these agents develop a much richer understanding of their environment.
So then they can make, I guess, smarter decisions.
Yeah, more informed decisions. Now, the paper also mentions these things called foundation models.
Are those sort of like the starting point, the basis of agent AI?
Yeah, you got it. Those large language models you hear about, like ChatGPT, they're the foundation.
Mhm.
A lot of agent AI is built on top of those. But agent AI, it takes it a step further.
It does, yeah.
It takes that brain power of a large language model and combines it with systems that can really interact with the world, whether that's like a virtual environment, a robot, or even a complex software system.
Okay, so we're taking this language model and we're giving it, like, hands to actually do stuff.
That's a great way to put it, yeah.
But then how do we stop those hands from doing bad stuff?
Yeah, how do we keep these agents from going off the rails? That's one of the biggest challenges.
That's what I was thinking.
These foundation models can sometimes hallucinate, meaning they'll generate outputs that are like factually or logically incorrect.
So they make stuff up, basically.
Pretty much, yeah. And imagine that in like a healthcare setting.
Hmm.
If an AI agent makes a diagnosis based on bad information, that's a huge problem.
That's scary, actually.
Yeah.
So how are researchers dealing with this hallucination problem?
Well, there are some promising approaches.
Yeah.
One is grounding these agents in really reliable knowledge bases.
Okay, so give them a source of truth to check their facts against.
That's the idea, yeah. It's like giving them a textbook to double check their assumptions.
I like that. So it's like fact-checking for AI.
That's a good way to think about it. Another approach is developing new training techniques that really encourage the agents to be more cautious, deliberate, rather than jumping to conclusions based on incomplete information.
So teach them to think twice before acting.
Yeah, precisely. It's tricky, but it's something that researchers are working on actively.
Well, that's good to hear. Okay, so we've got these powerful AI agents. They can take in information from multiple sources, and sometimes they might get a little creative with the truth. But where are we actually seeing agent AI used today?
Well, the research paper points to some really cool areas: gaming, robotics, and healthcare.
Let's start with gaming. I mean, who doesn't love a good video game, right?
Absolutely.
So how is AI changing the way we play?
Well, imagine a game where the characters you play against, the NPCs, they're actually powered by AI.
Oh, wow. So they're not just like pre-programmed characters.
Exactly. So instead of following a predictable script, these NPCs could actually learn from you as you play. They could adapt their strategies, and they might even surprise you.
It'd be like playing against another human.
That's the idea. The paper actually dives into this example called Cuisine World, which is this multi-agent gaming environment where AI agents work together.
Wait, so the AIs are like teaming up.
Yeah, they collaborate to complete tasks in a virtual kitchen.
So it's like a virtual cooking crew.
Exactly, and here's where it gets really interesting. These agents, they learn from each other's successes and failures.
Oh, so they're like getting better as they go.
Yeah, they adapt their strategies to become more efficient over time. And this ability to learn and collaborate, in a dynamic environment, it has implications that go way beyond gaming.
I can imagine, yeah.
We could use these same techniques to train robots for really complex tasks, like in a factory or even a disaster relief scenario.
Okay, so agent AI is changing gaming. And it has the potential to change, like you said, all sorts of industries like robotics. But what about healthcare? I'm both excited and nervous about the possibilities there.
Yeah, I understand. Healthcare is such a sensitive area,
Yeah.
but the potential is huge. Imagine an AI agent that can analyze medical images like X-rays or CT scans to help doctors catch diseases earlier.
So it's like an extra pair of eyes, helping doctors make better decisions.
Exactly. Or an AI agent that monitors patients' vital signs in real time, alerting nurses or doctors if something seems off.
Wow, that would be a game changer for hospitals.
Yeah, but then you also have to think about the risks.
Right. What if the AI makes a mistake?
Exactly. Who's responsible then? And how do we make sure that these systems are fair and unbiased?
That's a big question.
It is, and it's something that researchers and policymakers are actively working on.
Okay, so we've got AI agents that could potentially cook, assist doctors, and maybe even perform surgery someday. But how are these agents actually trained to do these amazing
But
things?
that's another really cool part of this whole field, and a lot of it boils down to data.
Data. AI always comes back to data, it seems like.
It does. Think about it. To teach an AI agent how to act in a complex world, you have to show it examples, tons of examples.
Okay, yeah.
And that could be text, images, videos, sensor data, all carefully labeled.
So it's like creating a giant training manual for this AI agent.
That's a good analogy. And the bigger and more diverse the data set, the better the agent will be able to learn and adapt.
But getting all that data and labeling it correctly, that must be a huge job.
Oh, it's a huge undertaking. And that's one of the big challenges in AI research, making this training process more efficient.
So it's not just about having more data, it's about using it smarter.
Exactly.
Okay, I'm starting to get a better understanding of how these AI agents are trained, but this research paper actually goes even further, breaking down different types of agents.
It does, and this is where you really see the wide range of agent AI. The paper categorizes agents based on, their capabilities, their purpose, and even the environments they operate in.
So we've got all sorts of different AI agents out there, each with its own unique skills and specialties.
Yeah, exactly. And the paper does a good job of mapping out this whole landscape of agent AI.
All right, well, this is definitely fascinating stuff, but I think we need to take a quick break to process all this information. When we come back, we'll dive even deeper into the incredible world of agent AI.
Sounds good.
So we've talked about how agent AI is more than just a chatbot. It's AI that can actually do things in the world. But this research paper we're looking at, it goes beyond just definitions. It talks about some really cool applications.
Yeah, and what's really interesting is how these applications kind of blur the lines between like the virtual and the real world. For instance, the paper talks about action agents in robotics.
Okay.
So imagine robots that aren't just programmed to do one specific task, but can actually understand and follow complex instructions.
Oh, like set the table for dinner or
Yeah,
help me pack for my trip.
exactly. Like that's the dream, right?
This is the kind of robot I want.
Totally. And researchers are using those big LLMs we were talking about to train robots that can actually understand natural language. It's like giving robots a crash course in human communication.
So we don't have to program every tiny little movement anymore.
Ideally, no. The goal is to just tell the robot what you want, like
Yeah.
you would ask a friend.
That would be amazing. But I'm sure there's some challenges there, right?
Oh, definitely. One of the biggest ones is this gap between simulation and reality. Like you can train a robot to do something perfectly in a virtual world,
Right.
but then when it faces the messiness of the real world, it might completely fall apart.
It's like that friend who's a great cook at home, but then they totally freak out when they have to cook in someone else's kitchen.
Exactly. That's a perfect analogy. So researchers are trying to tackle this what they call sim to real gap with a bunch of different techniques. Like they're creating these incredibly detailed simulations with super realistic physics, even like random elements just to throw the AI off.
Oh, so they're making it tough for the AI in the virtual world so that it's ready for anything in the real world.
Yeah, it's like a boot camp for robots. And they're also using a ton of real-world data to train these agents, so exposing them to, all the complexities of real environments right from the start.
Oh, that makes sense. Okay, so we're getting closer to that robot that can do all our chores. But the paper talks about more than just robots that can do tasks. It also talks about these things called generalist agents. What's the difference?
So think of it this way. A task-oriented agent, it's like a specialist, right? Really good at one specific thing.
Okay.
But a generalist agent, it's more like a jack of all trades. It can adapt to a wider range of situations, learn new things more easily.
Oh, so instead of having a robot for cooking, a robot for cleaning, and a robot for laundry, you could have one super smart robot that can handle it all.
Exactly, and that's where things get really futuristic. Imagine an AI that can help you with, like, scheduling, emails, even brainstorming creative ideas.
Okay, a robotic personal assistant that's actually helpful. Sign me up.
Yeah.
But seriously, how far off is something like that?
Well, it's still early days, but the research is moving fast. And one of the big challenges is data.
Data again. Shocker.
I know, right? But to train a generalist agent, you need to expose it to a huge amount of information, different kinds of experiences, tasks, environments. It's like giving it a crash course in being human.
So it's not just about having a lot of data, it's about having the right kind of data.
Exactly. And how do you even capture the complexity of human experience in a way that an AI can understand? It's a tough one.
Yeah, it's a big challenge. Okay, so we've been talking a lot about robots and physical agents, but what about the virtual world?
Ah, yeah.
This paper mentions something called simulation and environment agents. What are those?
Those agents are kind of like the architects or the builders of the AI world. They create and manage virtual environments, often to help train other AI agents.
Oh, so they're building the digital playground where all these other agents can practice their skills.
Yeah, exactly. Think of it like, training a self-driving car. You don't just throw it out onto real streets right away. You want to test it in a safe, controlled environment first.
Like a virtual driving school.
Exactly. And these simulation and environment agents are getting really good at what they do.
Okay.
They can create realistic 3D models, simulate traffic, even factor in things like weather and pedestrian behavior.
So it's like they're making a digital twin of the real world, where the AI can experiment without any real consequences.
Exactly. And the cool thing is, these virtual environments, they can be used for way more than just self-driving cars. They can be used to test new designs, simulate disasters, even create new entertainment experiences.
It's like the possibilities are endless.
Mhm.
Okay, we've got action agents, generalist agents, simulation agents. This paper also mentions generative agents. And those sound really interesting. What are those all about?
So generative agents, they're all about creating new things, like generating text, images, music, even entire virtual worlds.
So they're not just following instructions, they're actually coming up with new stuff, things that didn't exist before.
Exactly. It's like AI becoming a co-creator with humans. And we're already seeing this in fields like art and design.
Right, like those AI art generators. Those are pretty crazy.
Yeah, it's wild. But the potential goes way beyond just pretty pictures. Generative agents could be used to design new products, create personalized content, even build entire virtual economies.
That sounds like something out of a sci-fi movie.
I know, right? It's pretty mind-blowing. But it also raises all these questions about, like, what is creativity? What's the future of human imagination if AI can do all this?
Yeah, it's a lot to think about. This paper has definitely given me a lot to chew on. Agent AI is a huge field, and the applications are really only limited by our imagination.
Absolutely. And we haven't even touched on the ethical side of things. That's a whole other conversation.
Right. There's a lot to consider for sure. Okay, well, this has been a really eye-opening conversation. I'm excited to see what else we uncover as we keep exploring this world of agent AI.
Me too. It's a fascinating field.
All right, we're back, ready to wrap up our agent AI deep dive. We've covered the basics, some amazing applications, and even how tricky it can be to train these AI systems. But before we finish up, there's one more important thing we got to talk about.
Definitely. We can't really talk about agent AI without getting into the training techniques that make them so powerful. It's like trying to understand a great chef without knowing their recipes, you know?
Makes sense. Okay, let's get into it. What are some of those techniques? What makes these AI agents tick?
Well, one of the most popular techniques is reinforcement learning, or RL. We've touched on it a bit already. It's kind of like, training a dog with treats and rewards.
Right, classic trial and error. So the AI tries something, sees if it works, learns from its mistakes, and gets better over time.
Exactly. Like playing a video game, right? You try different things, see what happens, and figure out how to win.
So basically, the AI is playing a giant game, trying to get the most points or rewards and avoid the penalties.
Yeah, that's the heart of RL. But it can be pretty resource intensive, especially for those really complex tasks where there are tons of possible actions. That's why researchers are exploring other techniques too, like imitation learning.
Imitation learning.
Mhm.
So instead of just trying things randomly, The AI learns by watching experts do it, right?
Exactly. They get to see demonstrations of the right way to do something, often from human experts, and then they try to copy that.
Like watching a pro gamer and trying to steal their moves.
Haha, perfect analogy. And in some cases, that can be a much faster way to learn, especially if you've got good examples to follow.
Makes sense. It sounds like there's a whole bunch of different tools they use to train these AI agents, each one with its pros and cons depending on what you're trying to teach it.
Yeah, for sure. And researchers are always coming up with new and improved techniques, constantly pushing the limits of what these AI agents can do.
That's really cool. Well, we've covered a lot of ground today, from the basics of agent AI to some seriously mind-blowing applications, and we've only scratched the surface. There's so much more to learn and explore in this world of AI.
Absolutely. We've laid a good foundation, but there are always more fascinating details, more incredible possibilities to discover.
Well, I'm definitely feeling inspired to keep digging deeper into this whole world of AI, seeing where it takes us next. Thanks so much for sharing your expertise with us today. This has been an amazing deep dive.
It's been my pleasure, and remember, the journey of learning never really ends, especially in a field like AI, which is always changing and evolving. There's always something new to discover.
So true. And to all our listeners, keep exploring, keep those questions coming, and keep your minds open to the incredible potential of AI. Who knows what amazing things are just around the corner? Until next time, keep diving deep.